Hi friends, in last video we discussed how to convert the decimal number into any other number system. In this video we are going to discuss how to convert any other number system to decimal number. So before going to see the problem, we must know the procedure how to convert any other number to decimal number. So in order to convert binary to decimal, we need to multiply the individual digits of binary with respect to 2 power its place value, and to convert octal to decimal, the individual digits can be multiplied with respect to 8 power its place value, and to convert hexadecimal to decimal value, individual digits can be multiplied with 16 power its place value. So now we move on to the problem. The problem is that is binary to decimal. So the problem is given the binary number. We need to convert this binary number to decimal number 1100. So for this 0, the place value will be 0, and for this 0 place value is 1, and for this 1 the place value is 2, and for this 1 the place value will be 3. So the place value will be calculated from the last digit, that is LSB bit. So this 0 can be multiplied with 2 power place value, 2 power 0, which is equal to 0, and this 0 is multiplied with 2 power its place value, that is 1, equal to 0, and this 1 is multiplied with 2 power its place value, that is 2, 1 into 2 power 2 equal to 4, and this 1 is multiplied with respect to 2 power its place value, that is 2 power 3 equal to 8. So adding those values we are getting 12. So 12 is the equivalent decimal number for this binary number. So next problem, that is 110.01. So this is given in terms of fractional point. So 110 can be calculated as it is, that is for 0 place value will be 0, for this 1 place value is 1, and for this 1 the place value will be 2. So this 0 is multiplied with 2 power its place value, that is 2 power 0 equal to 0, 1 into 2 power place value, that is 1 equal to 2, and this 1 is multiplied with 2 power this 2 equal to 4. So adding all those values we are getting 6. And for the fractional part, the place value is calculated from MSP, that is this will be minus 1, for this 1 the place value is 2. So the 1 into 2 power the place value, that is minus 2, and for this 0 the place value is minus 1, that is 0 into 2 power minus 1. So 1 into 2 power minus 2 equal to 0.25, 0 into 2 power minus 1 equal to 0. So adding these two we are getting 0.25. So consolidate these two, that is 6.25 is a decimal number for this binary number. And the next conversion is how to convert the octal number to decimal number. 645 is the octal number. What is the decimal value of this 645? So we have to assign the place values. For this 5 the place value is 0, and for this 4 the place value is 1, and for this 6 the place value will be 2. So instead of 2 we have to use 8 over here for the octal number, that is 5 into 8 power the place value 0, which is equal to 5, and this 4 is multiplied with 8 power its place value, that is 1, 4 into 8 32, and this 6 is multiplied with 8 power its place value, that is 2, 6 into 64, which is equal to 384. Adding all those values we are getting 421. So 421 is the equivalent decimal number for this octal number. So the next problem is given in terms of floating point, that is 64.25. So for this 4 the place value will be 0, and for this 6 the place value is 1. So that is 4 into 8 power 0, which is equal to 4, and this 6 is multiplied with 8 power its place value, that is 8 power 1, 6 into 8 power 1 equal to 48. So adding these two we are getting 52. This is the equivalent value for this whole number. And for the fractional number, that is 0.25. So this for this 2 the place value is minus 1, and for this 5 the place value is minus 2. So 5 into 8 power minus 2, which is equal to 0.078, and for this 2 is multiplied with 8 power its place value, that is 8 power minus 1, which is equal to 0.25. Adding these two values, we are getting 0.328. So consolidate this whole and fractional part, we are getting 52.328. This is the equivalent decimal number for this 64.25 value. And next one is how to convert hexadecimal number into decimal number. The problem is given, that is 23e hexadecimal, that is equivalent radix is 16. What is the value of decimal? So 23e. So here also we have to assign the place value. For e, the place value is 0, and for this 3 place value is 1, and for this 2 place value is 2. So e into, for the hexadecimal the radix is 16. So we have to multiply with 16, that is e into 16 power its place value, that is 0, which is equal to e, and 3, which will be multiplied with 16 power its place value, that is 1. 3 into 16 power 1 equal to 48, and for this 2 is multiplied with 16 power its place value, that is 16 power 2, which is equal to 512. So we are using instead of e in decimal, we are using the value as 14, so which will be added together. So we are getting 574. So this is the equivalent decimal number for this hexadecimal number. So next problem, that is 1f.10. So this problem is given in terms of floating point. So for the whole number, we have to calculate as it is, that is for the f, the place value is 0, and for this one the place value is 1. So let me calculate here. So f into multiply with 16 power its place value, that is 16 power 0, which is equal to f, and this one is multiplied with 16 power 1, which is equal to 16. So instead of f, we have to assign the value, that is 15, added with 16, we are getting 31. So this is the result for the whole part. And for the fractional part, the place value will be this. For this 1, the place value is minus 1, and for this 0, the place value is minus 2. So we have to calculate here, that is 0, which will be multiplied with 16 power its place value, that is 16 power minus 2, which is equal to 0, and this one is multiplied with 16 power its place value, that is 16 power minus 1, which is equal to 0.062. So we are getting 0.062. So consolidate this two, we are getting 31.062. So this is the equivalent decimal number for this hexadecimal number. So in this way, we can convert any other type of number system to decimal number system.